Good morning, guys.
Morning, sir.
Okay, very good morning, one and all. So, any doubts in the previous day session, yesterday session, or you would you like to ask
No,
something
sir.
regarding this? No, sir. Everyone. Why? Because these are the steps for the next one. Okay, these are some of the basics for the next coming session, or today's session, or tomorrow's session. That is why I'm just asking you. If you are having any doubt in the yesterday session, in any point, kindly ask me. Okay, fine. Let's start the session.
Okay, sir.
Can anyone explain me the slide which we have we discussed yesterday? Anyone can
Input.
simply brief me on this one?
Sir, it is a process to convert the raw material with the help of some process into some output.
Okay. This is called as a manufacturing technology
Manufacturing technology.
or a manufacturing principle also. Okay. If anyone asks you what exactly manufacturing principle, then this is what exactly the formula. Okay. Next one. Same. This one. Number 52. Can you explain me this?
Evaluation of machine.
Yes. Evolution of missions. Can you continue this? What exactly is this?
Based on the efficiency, evaluation of machine.
Okay. Can someone give a brief on this one? On the first three?
Yes, sir.
Yes.
So this slide is depicting the evolution of machines. First one we have CM. They are conventional machines. From them, we evolve NCM. They are numerically conventional machine. So a controlled machine, and afterwards we get computerized numerically controlled machine. These are the machines, means evolution in machines. And the in bottom one, there this A automation and R robotics, and all these things comprises and make the industry 4.0.
Okay. Now, can anyone explain me what are the disadvantages of these missions? CM, NCM, and CNCM. For every
Skilled
mission.
labor is required.
CM
Okay.
for conventional machines, repeatability is not possible.
Okay. Then what will be the
For
disadvantage of
Sir,
instance,
CM
NCM?
is time consuming, also time consuming and drawback, repeatability, etc.
Okay. What about NCM?
like you cannot change the process in between.
Okay. Then what are the disadvantages of CNC missions?
For CNC, we need as number of as computers as we have machines.
Okay. Other than that,
More skill labors. Reliability. More
skill.
skill labors.
Yes, skill level,
And
speed.
inspection at every process.
Okay, fine. Next, I'm having a simple question. In the process evolution, there will be having automation and there will be having robotics. Uh, are they same or they are completely different? Automation as well as robotics.
Because sir, robotics is upgraded version.
Graded
So
version.
basically, automation is just bifurcating. Robotics is after bifurcating, we separate them using robotics rather than manpower.
Okay, fine. This one.
These are pillars of industry which are raw material, machine, process time, cost, and human workforce.
Okay. Are they dependent on each other or they are completely independent?
Dependent, sir.
Fine. This one, PLM.
First one is an academic version, second is an industrial version.
Okay. What exactly it describes?
So it describes the life cycle of any product, means how it is manufactured from zero to ending.
Okay.
And remanufacture.
Okay, fine. This one, industry, what exactly industry 4.0 in your words?
The digitalization of any industry is industry 4.0.
Yes, that is a simple definition. Digitalization of industry is nothing but industry 4.0. Okay. Now, in today's session, we are going to enter into the simulation part, which means what exactly a simulation is. So, how the simulation?
Excuse me, sir.
Yes.
Sir, I want to ask about sir PLM. Actually, I need slide of PLM. Yes, sir. In this first AMDIC,
Hmm.
explain, sir, this. I'm confusing what is it
Okay.
exactly.
See, this is the first one. DE is nothing but design. Okay. Any idea or any product starts with a design only. After that, it will be entering into manufacturing phase. This is the second step. And the third step is nothing but once the manufacturing was done, once I'm having the output with me, then I need to distribute it to the customers. That is distribution. Okay. And again, it will be entering into customers or consumers. After the distribution, suppose customers need to purchase that one. That is why C. It's nothing but customers or consumers. Once it is with the consumers, it is a, they will be used it. Once the usage was done, once the life cycle of the product was done, then they need to follow some sort of EOL, end of life. That is nothing but the product end. So if it is a recyclable product, we can reuse it. If it is a non-recyclable product, then there should be having certain procedures to follow for end its life, like a polythene. So for polythene, there will be having some certain things we need to follow. Then only it will be recyclable or it will be completely disposed. Like for every product, there will be having some EOL that will be written in the industry point of view, which is not disclosed with the customers. Just example, our computers. Once the computer usage was done, one or old PCs the usage was done. What we are going to do? So we don't have that recyclable thing. Then we'll simply sell it or something. Then again the industry person, they will purchase it. They will remove all the lead parts. They will remove all sort of useful things from the, I mean, motherboards, from the chips and all the things. Once the non-recyclable, once the hazardous waste is there, they will try to restore, they will try to end its life by their some of the chemical compositions. Like for every product there will be having some EOL, which is defined with the industry only, that is called as a EOL. Okay. You want this
Okay,
also?
sir.
You want this too, or is it clear with this one? Typical. Okay, no problem. I explain you. So this is a simple PLM. When comes into industrial PLM or a typical PLM, so every product starts with an idea or innovation. If it is a newer product, then it is an idea. If it is an existing product, then I'm going to upgrade it. Then it is called as an innovation. So every product starts with this one. This is the first phase. That is called as an idea or innovation. Once my idea is going to, I mean, I want to showcase my idea to some other, then it should be having some skeleton or representation to check how exactly it will be visible. Then we are going to use this design phase to prepare this idea into a actual, I mean, virtual one. Once the design was done, then I am going to manufacture it. For the manufacturing things, what are the different things that need to consider? So how exactly I am going to manufacture, what are the different components or missions that will need for the manufacturing? That will be nothing but a development phase. Once I am having these two documents, then I am going to prepare, I mean, prepare some prototype of the component which I am going to manufacture. Prototype is nothing but for a testing purpose. Hardly we are going to produce some 5 or 10 number of components based upon the test we are going to produce. If the number of test is 10, then we are going to produce 10 number of parts for each and every test. So once the testing is also done, then we are going to production. Once the part is failed in the testing phase, then again we will be going back into this phase, design phase. We are going to do the upgradation, and it will be like a completely recyclable. So once the part was done testing, once the part is accepted from the testing team, then only it will be entering into production team, where we are going to produce the part in a mass production. Whether I'm going to manufacture it for 100 or 1,000 based upon the demand or based upon the things I want to produce, this is depends upon this production phase. Once I'm having some output ready with me, then I am going to supply it to the customers. Once the supply was done, then the part is with the customers. Then what is the thing I need to do? So for the product upgradation, I need to collect some feedback, that is known as FB. So I need to collect the feedback for all the pros and cons of the product, for all the positives as well as negatives of the product, how exactly it is with the customer. So what are the, if there are any limitations or if there are any upgradations from the customer side. So we're going to collect all the things from the customers. Once the list was ready, then we will going to save it to the R&D team for the product upgradation, which is nothing but again. So there is a product, there is X product, if at all there are some negative things, so I want to improvise that. So now I'm collecting all the negative things and I want to try to improvise that. That is nothing but this product upgrade. Once this product upgradation was done, then I will be launching that product with all these things, then I will be using some sort of version. So this is called as a typical PLM. It is a simple PLM. Clear?
Yes, sir.
Now this side. Okay, in this session we are going to discuss about the simulation, what are the simulation basics, and like yesterday, once the session was done, then I will be sharing you this slide whether we have completed or not on all these things. Okay, first thing, the main introduction slide is plant simulation. Okay, before entering into all these things, first of all I will explain you what exactly a simulation is. Okay, simulation is nothing but testing. Okay, simulation is nothing but testing. Here we are not using any physical parts for doing the testing. Here we are using a virtual part. I mean, there is a design file is there. If at all I want to manufacture some laptop, okay, so how exactly it is moving, how exactly it was closing, so what is the tolerance, how it was operating, so all those things virtually I need to create the model first. Once the model was prepared, then I am going to check that part. So how exactly I'm going to check? By using various simulation softwares to check how exactly it was working in a virtual atmosphere. I'm not producing any actual part here. This is called as a development phase. I will say this is in the development phase. In the development phase, we are going to use this type of softwares to prepare the facility of the part which we are going to produce. So simulation is nothing but virtual testing. So where we are going to test our parts virtually, that is called as a virtual testing. If it is actually I am having a part with me, physical part with me, then directly I will go to the, I mean, if the part is having some stainless steel or something, then I am going to directly test it for the material properties or some by using some different kinds of things like missions, tensile testing, impact missions, all those things I am using this material for testing purpose. If at all I'm not having a physical part, then this should be the thing, simulation where we are going to check our part virtually. Okay, that is called as simulation. Now in this we are going to use the name is a plant simulation, which means where we are checking our plant virtually. Plant is nothing but industry, where we are checking the industry virtually. That is what exactly the software name is, plant simulation. Which means we are going to create a layout of the plant and we are going to check all the parameters involved in that layout. If the layout is having 5 CNC machines, conveyors, cranes, robots, human, everything is involved in it, I'm going to check each and every parameter involved in that plant. That is called as a plant simulation. In simply, we are going to check the facility of the plant or facility of the layout. That is called as a plant simulation. Now, I'm going to explain some sort of definitions which are given by different companies. Okay, plant simulation is a computer application software for modeling, simulating, analyzing, visualizing, and optimizing production systems, process, flow of material, and logistic operations. See here, plant simulation is a computer application. Like I already told you, this is a virtual application. So it's a computer-based application for modeling. I hope you know what exactly modeling is, right? Okay, fine, I will explain you in that also. Modeling is nothing but creating. Okay, modeling a part is nothing but creating a part. Modeling a plant is nothing but creating a plant. So modeling is nothing but creating. Okay, next one is simulating. Like I tell you, simulating is nothing but testing. Okay, simulation is nothing but testing. Now what is this analyzing? What is this analyzing?
On the basis of the test results from simulating to analyze the product and make improvements.
Yes. Simply analyzing is nothing but comparing.
Analysis.
Analysis or comparison. So actually I am having some 30 percentage of efficiency for actual mission, whereas in virtually I am getting 45%. Now what I need to do? I need to compare these two results. On what basis here in actual I am getting 30? On what basis in the software I am getting 45? I need to do some analysis part. That is nothing but a comparison or checking on all the aspects that are related with these two similar missions. This is actual and this is a virtual. So why exactly this difference will be there? 50 percentage of difference is there. So I need to do all the analysis part. That is nothing but analyzing the results or analyzing the model is nothing but checking or comparing the models. Next one is visualizing, which is nothing but how exactly we are viewing the plant. So I have prepared a product, like there is a yesterday we have talked about a discussed about an example, cellular phone, mobile phone. This is a rectangular phone. Now I want to produce circular phone. So this is the circular phone. Now I want to check how exactly this will be visible. Okay, for producing this part, what are the different type of layouts I want to produce at each and every type layout at each and every mission, how this part is placed, all these things, that is called as a visualizing, how it was visible in actual, that is visualizing. And optimizing production systems. Optimizing is nothing but, what is optimization? Any idea on this word optimization?
Increasing efficiency.
Increasing efficiency. Okay, that is an outcome of an optimization. Simple thing, optimizing is nothing but limiting the resources, limiting the things involved in it. If at all I am using 100 number of missions for producing 10,000 components, if at all I want to do some optimization, then by using 100 I am getting 10,000. Now what will happen if I use 99? If at all I am getting 10,000 by using 99 also, then there is optimization, which means limiting the resources, limiting the everything, and getting this efficiency, getting this final mark. That is called as optimization. Now see, now you only tell. There are 100 missions in first case and there are 99 missions in second case. In each and every case, I am getting 10,000 number of components. Now, which process I am going to pick? First process or second process?
Second, sir.
Of course, second. Why? Because this is a optimization. In the first, it is the actual one. It is not optimized. In the second model, this is an optimized model. In that, I have tried to eliminate one mission so that my plant is. I am getting 10,000 components. Now, what is happened? I am not using one mission. So because of this, there will be having a resources that will be kept vacant, and there are a lot of the things that will be kept free. That is why I am getting this output. At the same time, I am getting efficiency increased. This is called as optimizing. Okay, optimizing of what? Different types of optimization, that is called the production system, which means if at all I am going to produce this type of circular cellular phone, okay, from this phase to this phase, this is called as a production line. So if at all I am going to optimize the production line, that is optimize. Then process. So I am following some set of process. If at all I want to modify that, if at all I want to reduce the process involved in it, if a product is moving from this point like this, if a product is moving in this much of race, and this is my output, okay, input and output, first mission, second mission, third mission, fourth mission, fifth mission, sixth mission, and seventh mission, eighth mission. uh, just a second, is it visible? Or it was stuck?
Yes, sir.
Yes, sir.
Yes, sir.
Now there
Yes,
are
sir.
now there are 8 missions here. 1, 2, 3, 4, 5, 6, 7, 8. Now the missions are here, but the material movement is this much. This much of material movement is there. Now I want to reduce that. That is called as a flow of material. So instead of moving this much, what will be happen if I try to do like this? What will be happen if I try to move like this? What will be happen if I try to move like this? What will be happen if I try to move like this? Because of this, what will be happened? My material movement rate, previously material is moving in this direction, because of which my time is wasted, my process flow is wasted, material is moving unwantedly, unnecessarily, all those things, there will be a lot of wastage will be there. Now I want to optimize this. This is called as a flow of material or process optimization. Okay, finally, and logistics operation is nothing but, uh, just a second, here there is a material is there, okay, there is a AGV or there is some truck is there, the truck is full of material. Now I want to give this material to this first mission. For this, the truck is need to go like this: first mission, second mission, third mission, fourth mission, fifth mission, again coming back. This is the mission. If at all I want to I want to constrain this movement also, the material movement, on how exactly, that is called as a logistics of, okay, logistics operation. Now I will be erasing all these things. Now we will be discussing these things. See, plant simulation is an application where we are going to create our model. Once the creation was done, then we are going to virtually testing. So once the testing is also done, then we are going to analyze it, which means on what basis, whether I am getting high efficiency or low efficiency, I want to test that. So once the testing was also done, then I am going to clearly see the picture on how exactly it is visualizing. So once after these four things was done, then we'll be having these things with us, like optimizing. So once after doing the optimization only, then we'll be doing this, different parameters. So we are going to optimize on the production process, flow of material, as well as logistics material. Okay. In simply, plant simulation is a software where we are going to create our part or a plant, and we are going to do the optimization for better efficiency. Okay, simple definition: we are going to create our plant for what purpose? For optimizing the plant, finally for increasing the plant efficiency. Creating, optimizing for better efficiency, that is called as a plant simulation. Okay, that is one set of definition. Second set of definition is performing an operation or task without physical means. Same here, we are not involving any actual plant or actual mission, actual robot here, actual human here. Everything we are going to create or we are performing is virtually only. If the plant is having 10 humans involved in it, now instead of 10, I have removed some 4 humans and I have run the plant with 6 humans. So which means in actual I am not removing or not deleting all these things. In virtually, I have tried to do the optimization part, whether this part will going to run or not with the 6 men. That is, I am checking with a virtual platform. That is what exactly it is saying: performing an operational task without physical means, without involving any actual missions or actual things involved. Okay. Now it is a software that enables the analysis of, let me erase all these things. Third part, it is a software that enables analysis of material flow. Like already explained you, material, the movement of material from one station to another station, this is called as a material handling or a material flow. So this material, we can also do the analysis part for the material flow. Resource flow. Now what is this resource flow? What are resources of a plant? Any idea on that?
Raw material, manpower, electricity.
Some bells which we use which we use in material flow.
Mm, okay, fine. I'll explain you. So if there is a mission is there, some X mission is there. If at all I want to run, there is a input that is waiting for the operation here, and there is some output. There is some bin that need to produce, that need to collect the output. This is a X mission. Now, if at all I want to run this mission, now what are the things I definitely needed? Let us assume this is a CNC mission, CNCX. Now I want to run the CNCX mission, for which what are the different things that is needed? What is the first thing, first basic thing or a primary thing that is needed for the CNC?
Raw material.
No, basic thing is nothing but electricity.
Power.
Okay,
Electricity.
electricity.
Land.
Once the electricity was done, second is land, as said, land. Third one,
Operator.
okay, human operator. Next,
Softwares.
okay, software. Okay, software. Now see, I'm having
Workpiece.
workpiece. Okay, fine, workpiece here. So we are having workpiece. One of the important thing. So if the workpiece is coming, if the stainless steel is having some this much of shape, and I want to do this hole, okay, I want to do this milling purpose or some drilling purpose, I want to remove this part. Now what is the thing that needed? The part is fixed in the CNC machine. Now what is the thing needed to do this operation?
Tool.
Yes, tools. And so if it is a metal, then what will be happen? Definitely there will be needed some of lubricants. These are all for running a mission or for running a facility. The things that are needed nothing but a resources. Okay, resources are nothing but if at all I want to run a plant, then there are some essential things that will be needed for running a plant or running a mission. Those are called as the resources. In the first thing, we are running with a material flow. This is called as a material flow. Second one is resource flow. If at all I want to run this setup, so what are the basic things that will be needed? That is called as a resource. Next one is utilization of missions, which means here there are 5 missions. Out of 5 missions, only 4 missions are using 1, 2, 3, 4. These are the 4 missions that are used or that are completely used. That is called as utilization of missions. On what basis these 4 will be used? Why this mission is not utilized? If at all this mission is not utilized, then why it was placed in between the process? Like we need to do that analysis also. That is utilization of missions. Or else this mission was used more than 80 percentage, whereas this mission is used 20 percentage, and this mission is 30 percentage. Again this mission is 80 percentage, again this mission is 90%. Now we need to do the analysis part. Why this much of difference is happened? So why there will be having a fluctuations in operating in all these things, that is called as the analysis. Next one is operations management. Like explained to you, if this much of efficiency is there, then there will, that is definitely by the operations only. What sort of operations we are performing? Why this mission is having 80 percentage and why this mission is having 20 percentage? What are the different operations we are adapting between these two? That is called as operation management. Next one is a human operations. If these 5 missions will be having 5 humans, H1, H2, H3, like H4, like H5. 5 different human are there. Now each and every mission will be having some 1 hour of processing time. I mean working time. Mission 1 is having 1 hour. So if a part was loaded here, so after 1 hour only this part is going to coming from this mission. Okay, 1 hour is PT processing time. Like 5 different missions is having 5 individual 1 hour. Now, do I need 5 workers here or 1 worker is enough?
One worker is enough.
According to, okay, it's based upon the thing. So we can do the operation with 1 worker also. Why? Because the processing time is 1 hour. So once the part will be loaded at that time, so this human was kept vacant for 45 minutes. Next 45 minutes, in that 45 minutes he is having some other work. He will be going to some other mission and he will try to load that part over there, because of which what will be happen, this human effort will also be reduced. That is a analysis of human operations. Logistics for manufacture planning and many more. Logistics, like already told you, if these 5 missions were there, so there need to be some truck that need to distribute material to each and every mission. How the truck is coming, how the material movement is happening with these trucks, this is called as a logistics. Internal material movement with help of a truck is called as a logistics. So how the material movement is happening with the trucks in between the stations, in between the process, that is a logistics. In simply, this software is having a capability of creating the plant. Okay, after creating, then we are going to simulate it and we are going to analyze it. What are the different capabilities that we are going to analyze? These are the different areas: material flow, resource flow, utilization of missions, operations, human management, logistics. So what are the parts that will be involved in a plant? Every part can be analyzed by using this software. Okay. Next one is, in other terms, it is a platform where we can create or run our own process for achieving maximum efficiencies in terms of production. I hope it is clear. In terms, it is a platform where we can create and run our own process for achieving maximum efficiencies. That is what exactly we are doing here. So we are creating a model and finally we are going to improvise that model. Okay, by doing all these areas, by doing simulation, by doing analysis, by doing some optimizing, and finally we are trying to increase our efficiency. This is one form of definition. Simulation is an intimation of a process in a model that you can experiment with, achieving the results literally. So these are the different forms of plant simulation definitions. Okay, but in detail, in simple, there will be having one definition, that is this one. Plant simulation is a platform where we can create or run our own process virtually for achieving maximum efficiencies in terms of production. This is the best and apt definition for the plant simulation. Okay. Here simply plant simulation where we are going to create our plant or a industry. So we are going to create our industry with having some processes, everything involved in it. And finally, we are going to increase the efficiency of the plant. That is what exactly the main capability of plant simulation. This is a simple definition. Plant simulation is a platform where we can create or run our own process virtually for achieving maximum efficiencies. Clear with the definition?
Yes, sir.
Yes, sir.
Why?
Yes,
Because
sir.
whenever you are going to say that I know the plant simulation, or I am capable of doing plant simulation, or as I've trained on plant simulation, then the first question will be what exactly is a plant simulation, or what is it capable of? This is the next question. Then this should be the definition. Plant simulation is a virtual platform where we are going to create the any type of process. For what purpose? For increasing the efficiency. That is a simple definition of the plant simulation. What are the I mean, what are we are going to do in the plant simulation is nothing but we are going to do the analysis part of the plant. Different forms of analysis, like I explained in the previous slide, like material flow analysis, resource flow, human analysis, like different forms of analysis we are going to conduct in the plant simulation. Okay, this is the definition of the plant simulation. Now, second step is this plant simulation works with the 5D concept. Okay, this 5D concept is nothing but I'll explain you here. It was written, but I will explain you. Uh, Let me. Okay, what happened? Okay, leave it. In this plant simulation, I'll leave the plant simulation now. I hope you have used these graphs. This is the origin, this is x-axis and y-axis. If there is a point here, okay, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. This is 7 and this is 4. This is a point A. Now what are the values of point A?
4, 7.
Okay, 4, 7. How you set this? On what basis you have?
Coordinate system. First you put the value of x and then you put the value of y in the bracket.
Okay, so what is that form of coordinate system you have used as a reference? What sort of coordinate system you have used as a reference?
So two dimension.
Two.
Fine. Two dimension. There will be having, I mean, two coordinate systems, that is called as absolute coordinate system as well as incremental coordinate system. Okay. These things I will explain you when the actual topic comes, but we are going to follow either of these, which means 0, 0 as a reference. At this point, 0 and 0 is a reference. With this, we are going to conclude x as a 4 as well as y as a 7. Okay. Then we have given 4, 7. Now, if the value is 4, 7, then this part is in which? I mean, is in a space or in a plane or is in a point or a line?
So plane.
Plane.
Okay, which means plane is having
Two
plane.
dimension.
Okay, plane is having only two coordinates, or simply it is called as a two-dimensional. If it is a it is having only one point, then what we supposed to call as a
Line.
1D
Right.
or line. If it is having three dimensions, then what we supposed to call it as a
Plane.
plane? No.
Space.
Yes, we'll call as a space. Now, if I consider this in a space, now what are the points? I have given some z value also here, and it should z is at some 50. Now, what will be the point? 4, 7,
50.
which means this is a three-dimensional object. This object is a three-dimensional object. Okay. For every object which we are going to manufacture, will be having a three-dimensional 3D values. Okay. So if we are going to prepare, I hope you know AutoCAD software, right? Some basic software.
Yes, sir.
In that you will be drawing a sketch. Sketch is nothing but a 3D or a 2D. So this is
So
what,
2D.
yes, this is I have prepared. It is 20 and it is some 7. Now what I supposed to call this as a? It is a 2D or a 3D? Sketch.
2D, sir.
It's a 2D. Why? Because it has given only x as well as y. So it was written as a 2D dimension only. It is a plane. Okay. Now if I have given this dimension now, and this is some 10. Now this is a plane or this is solid?
Solid.
It's a solid part.
Solid.
So for every solid part, there will be having 3D values, which means it is having x, y, and z. So this plant simulation will be considering 5D simulation concept. In the 5D simulation concept, first three is nothing but three-dimensional, which is x, y, and z. Which means the part which you are going to manufacture, whether it may be a chair, whether it may be a helmet, whether it may be a phone, whether it may be a fan, or whether it may be a shoe. So irrespective of the component, it is having some 3D dimensions, which means it is having x, it is having y, as well as it is having z. Okay, then we will call it as a three-dimensional. Even the missions which we are going to use, the mission is a 3D mission, which means the mission should be like this. So it is having three-dimensional values. It should be like this, three-dimensional. Okay, next one is fourth D as well as fifth D. Fourth D is nothing but time. Why time is essential in simulation? Three-dimensional why we have given is for every component they definitely need x, y, and z dimensions. That is why we have given three-dimensional as one of the key important factor on the 5D simulation. Then the next two are time as well as cost. Why these two are essential for plant simulation?
To estimate the completion of the product in real life.
Okay. See, while explaining you the pillars of an industry, I have given you example with a conventional as a CNC machine. In that, I am going to produce n number of components. In that n number of components, I am going to calculate the time, which means by using a conventional machine, what is the time estimated TC? Now, what is the this one? By using this one TCNC. So I need to estimate this also. Why? Because this is also one of the key factor in the simulation. Simulation with run with respect to the time only. Okay, this all the simulation concepts runs with respect to time only. Okay, that is why time is one of the major dimension in the plant simulation. That is a fourth dimension. Fifth dimension is nothing but cost. Same, I have explained you cost also. So if at all I want to use a CNC or a conventional, which one I am going to pick? Based upon the components I am going to produce, I am going to pick the cost. So if at all I am using conventional, how much cost it is involved? If at all I am using conventional machine, CNC machine, then what is the cost that will be involved in preparing a part, incurred in preparing a part? That I need to adapt. This also plays a crucial role in industry perspective. Okay, now this is what exactly the plant simulation always works with a 5D concepts. In that, three dimensional is nothing but a part, and a fourth dimension is respect to cost, as well as fifth dimension is respect to time. So these are the different dimensions in a plant simulation. We can run and perform any simulation based upon the usage involvement on the above. Okay, clear with this thing? Clear with the definition as well
Yes,
as
sir.
clear with 5D concept?
Yes,
Yes, sir.
yes.
Fine. This discrete, I will explain you at the end. I mean, while showing you software, I'll explain you what exactly discrete event simulation. Okay. Now, if I explain you, then you will be getting confused. So I won't touching you this point. Now, so I have explained you what exactly a plant simulation is. So for starting, I mean, for starting anything, there will be having some certain procedures. Like if at all I want to draw some layout or drawing, I want to prepare some type of component like this. For drawing this, there will be having some certain process, like what exactly the starting point, and now where exactly I am going to pause, where exactly I need to check the dimensions, what is the type of angle I need to produce. So what is it, whether I am going to produce a clockwise or anti-clockwise direction. Like for drawing this, there will be having some certain procedures. Like even for creating a simulation project or for creating a plant, for creating a simulation, they definitely need some sort of procedures. For that, this is having the complete procedure. So the for starting a simulation, these are the things we need to consider before starting a simulation. That is nothing but decision for plant improvement, for higher production optimization process. Then these are the three essential things you need to consider. First one is a planning phase. One thing I want to explain you, this simulation is if at all I'm going to start a plant, or if there is a existing plant is there, I want to do the modification on that, or I want to start a new project. So for that, I mean, before starting the actual plant only, we need to go the simulation, we need to check the simulation, we need to create the simulation. Otherwise what will be happened, if a plant model was established here, so if this is the plant model, I have placed these many number of, I mean these many missions here. Once after placing this here, if at all I have created the simulation model, and now I got a result that this is not going to place here, this supposed to place at Prasad, Krishna, Maladi lab, advanced manufacturing, then it is impossible for me to, I mean, relocate all these things. That is why if it is a newer project, before starting a newer project, we need to create a simulation model, and we need to check whether the model which you are going to prepare will balance, I mean will give the impact or not, will give the best efficiency or not. We need to check before starting a plant. Okay, for that, for creating a plant, for creating a newer project or anything, then we are going to follow, definitely follow these things. First one is a planning phase. In that planning phase, first one is impact of change in production process. Now what exactly it would be, impact of change in production process? 1 2 3 4. Okay, there are 4 missions that are involved in this one. Impact of change in production process is nothing but, I am using this type of procedure: 1 2 3. After that again it will be coming to 2, again it will be going to 4. So this is what exactly my layout will be. If my layout is like this, then where exactly it will going to fail? Guys, is it clear? Okay, let me clear it.
एक्चुअली सर आपकी आवाज ब्रेक हो रही है कुछ देर से। आप
Okay,
एक बार रिपीट करेंगे आपने क्या बोला?
okay, fine. 1 2 3 and 4. I am explaining you this one, impact of change in production process. In that there are 4 missions: first mission, second mission, third mission, and fourth mission. My production process is, the material need to go like this. Okay. Okay. The material is supposed to go like this. What happened? 1 2. After that it will be entering into 3. Again after 3 it will be coming back to second position. Again it will be going into 4. Okay, so this is what exactly procedure: first mission to second mission, second mission to third mission, third mission to, again it will be coming back to the second mission, and once it was done, again it will be back to the fourth mission. So if this is the process, then where exactly this process going to fail? Any idea?
There's a bottleneck at 2 and 3 if the production uh, basically the 2 is taking input from 1 and 3 both the sides, so the speed of 2 will be small, will affect the production rate.
Yes. Here what happened is, there are 4 missions in which the second mission is having input from first mission in the initial run, so it is running perfectly. Now after 1 minute or after 5 minutes, what happened? The parts from this third mission again entering into second mission. Now what happened? The parts from this third mission is also entering. At the same time, the parts from the first mission also entering. So because of this, there will be having use load on the second mission. Because of this, what will be happen? There will be having a material weightage. We will call it as a bottleneck, or simply we will call it as a waiting phase. Parts from first station and parts from third station. So this is a parts from third station. Parts will going to wait here. Once it was done, then the part will be again entering into fourth mission. At this condition, the mission is having a huge load. At the same time, there will be having lot of material that in the waiting phase, which is called as a loss for an industry. If at all these type of processes is there, to improvise that, so if at all I want to do this one, how exactly I need to do, that is called as the impact of change in production process. So if this was there, now I want to replicate it. If the load is more, now I want to, I mean, deviate this one. Instead of coming from 3 to 2, I am creating a newer mission. 1, 2, 3, 4. Now I am placing a fifth mission here. So what will be happen? The material will be coming like this 1 to 2, 2 to 3, and again it will be coming to 3 to 5, and it will be going to 3 to 4. I'll try to involve this one. This is called as the impact of change in production process. Now I need to check. So what will be happen if there is a lot of production, lot of bottleneck will be there in the production. This is one of the example. I will give you one more example, simple example with which you will be having clear idea. 1, 2, 3, 4, 5. This is a production line. Okay. So where we will be having 5 different missions. Now this is continuous. Whenever the input is coming, so it need to go through each and every mission, and after fifth mission there will be having output that need to be collected. Suddenly at the third mission was having some breakage, or it will be having some failure. Now what will be happen to the production?
Production will stop.
Production will stop. Why it was stopped?
So because it has third has faults in it, so we can't go forward
Yes.
without doing third.
This is a step-by-step procedure, which means the part you need to enter into each and every step, then only it will be exiting from this one. Whereas third mission was failed, because of which what will be happened, this four or fifth mission will kept, I mean it will be idle in state, and if this third mission will be having some 5 hours of MTTR. MTTR is nothing but mean time to repair, or for repairing this machine is having 5 hours of time. Now what will be happened for this 5 hours? The production need to be in halt position. It will be a huge loss to the industry. Now as an engineer or as a production engineer, if I have given the same condition to you, so what you are going to suggest to improve the process? I want to run this complete process. Now what will be the alternative for this?
So we will bypass the third one. We
What?
can make an alternative machine in place of three.
Okay, see, I will be explaining you something. 3. Okay, these are the process in the first mission. There will be having a face milling. Second mission there will be having a small drilling D1. In the third mission there will be having a D2 as well as a chamfer cut here. In the fourth mission, this is a 3, and in the fourth mission there will be having an edge cutting. There is again having a side chamfer, and the fifth mission there will be having a tapping as well as boring. Now this mission was failed. Now what will be happen if this mission was failed? If I bypass this mission and directly make the part enter here. Now, is it possible to get the shape, desired shape directly here? So we can't bypass the process here. Now what will be the alternative? We should be having a backup mission. We should be having some sort of alternative mission which will be capable of doing the same 3 operations. This is nothing but 3 dash. I will be saying is a 3 dash. So which means whenever there is a mission, whenever there is a failure that is adapted in this one, so I am going to give the product to this one, and it will be entering here. Because of which what will be happen, my production is not halting, I mean not pausing, so it is continuously moving from one area to another area. So even though it is having a failure, so this is what exactly impact of change in production process. Instantly if there is a failure, or if there is a something failure happened, let us take one more example. These are all CNC missions. Okay, CNC, and this is a conventional mission. Now yes, I can do this. Why? Because instead of waiting 5 hours, I will go, I mean, I will use a skilled labor at this position. I will try to do this optimization. I will do this continuous process here. I will try to do the material, and I will process it for the next run. But I will collect this batch for the inspection purpose, whether I have met the, I mean, inspection criteria or not, design criteria or not in the later phases. This is what exactly the impact of change in production process. Clear? In a continuous running environment, what will be happen if suddenly a impact was there, if a failure was there, if a failure in the process was happened, or if there is a failure in the material handling, like a truck is picking a material and it is coming to this station and it is going to deliver here, but because of there is some tire puncture or there will be having an engine problem with the truck, so the truck is not moving here. Now what will be happen? Will the production will be halted? Will the production will be stopped? No, it won't be stopped. There will be some alternative means. There will be using some manual loading, or they will be using something to overcome this one, and they will try to give the material to this. Maybe this one is a slower, but instead of stopping this process, they will be using this as a alternative method. This is called as the impact of change in process. This is the first thing we need to consider before starting a process. Okay, so this is my prescribed process, and in this process what will be the alternative? If a failure was happened, what will be the least outcome? What will be the repair? How much? If the first machine is having failure itself, then what will be the impact? If the last machine is having failure, now what will be the impact? Like, we need to calculate all the different impacts on the production process. This is the first point. Second one is reducing the WIP inventory. Now what is this WIP? WIP is nothing but work in progress. Now what is this? If you go to an industry, then you used to hear this word. Sorry, work. You will be hearing this word continuously. WIP inventory, WIP progress. Everywhere you will be hearing this word. Now what is this WIP?
Work in
Raw
progress.
material,
Work in
Progress.
yes. What is a work in progress?
so the raw material which are already in the process.
Raw material is already in the process. Okay, somewhat agreed. Then other than that,
Work is going on. Some means somewhat work is being done.
okay, fine. I'll explain you. This part is entering here 1, 2, 3, and 4. In the first mission, there will be having continuous input, and for the first operation, there will be having some set of 10 missions. Out of these, okay, 1, 2, 3, 4, 6 missions. Each and every mission is having input for the first operation. After the first operation, there will be having some 1000 parts with me. Okay, and for the second operation, there will be having 4 missions only. Now these 4 need to be mapped to this one. Okay, now the third mission, again the third process is having 4 missions, so it will be running continuously for the same 1000, whereas the fourth part is having only 2 missions. Okay, the material waiting rate before the work, I mean before the mission, is nothing but work in progress stations. I want to reduce that. That is called as a WIP inventory, which means the part is ready and it is waiting for the mission to do its operation. That is called as a work in progress. Okay, clear? See, there are here missions, continuous missions will be there. If the single part is coming, it will be exiting directly. So it will be like this. Then there will be no any WIP inventory. Why? Because it's zero inventory. Whenever a part is coming, it will be directly entering into second mission. Same, it is happening simultaneously. So at this position, there is zero WIP inventory. But whereas for the first process, there will be having n number of missions. If the second process is having some limited missions, the third mission is having again large number of missions, fourth is having limited. This is going to happen in industries. Why? Because the raw material is coming from different parts and different missions. There are some set of missions that is doing only the first part, first operation. If let us take an example like potato. So what will be happen in a potato chips? So there will be having some set of 10 missions, 10 cutting missions. It will collect the mission and it will slice it continuously. The part is slicing it. So whenever it is having some 10 tons of some 10 tons or 20 tons of load, continuously it is giving the input here, I mean the output here. There will be having a lot of output. Whereas in the second section, it is going to, I mean it is a peeling section. In the peeling section, it will be like this. In the second section, it is a cutting section, whereas the cutting is having only 5 missions. Now what will be happened here? There will be lot of material that is waiting here. After the peeling section, there will be having a boiler. There is only one boiler. Okay, in that boiler there will be having 3 inlets or 5 inlets. The material is waiting here. The material that is waiting here, this is called as a work in progress, WIP inventory. Okay, which means the part is ready and it is waiting for the second mission to done the operation. That is called as a WIP. Okay, in industries, WIP inventory will always be a Disadvantage. Why? Because the parts are ready for doing this operation, but machine is not, I mean, machine is not available for doing that. Which means what exactly it is? It's a failure. My part is waiting for the mission, at the same time mission is not, I mean, mission is completely occupied with some other object. So in the meantime, what will be happen? This part is waiting. This part is a waiting phase. If there is an alternative mission, let us take two missions. There are two missions, mission 1 and mission 2. If there is a one part that will be entering here, this mission is kept vacant. There are three parts. Okay, first part entered here, second part entered here. It will be having some half an hour of processing time, same half an hour of processing time. In the meantime, there are parts that will be coming like this in the conveyor. Now this is called as a whip, which means the part is coming here and it is waiting for the mission. This is a drawback. If at all I am having four missions, then automatically what will be happening? This part will be entered here, this part will be entered here. There is no any material weightage in the conveyor for operating, for to, I mean, for get the work done. So this is called as a WIP, work in progress. So industry will always try to reduce this WIP inventory. Okay, clear? We are going to work in the software with this also. So when we are using conveyors in this, if the conveyor is having a material like this, and if the material conveyor is having this much of material and machine is having processing one part at a time, then I'll say this as a bottleneck or a WIP inventory. In technical we will call it as a bottleneck, in theoretical we will call it as a WIP inventory. Clear? Next one is,
Yes, sir.
next one is mission utilization status. In the previous slide, I hope I have explained you what exactly mission utilization status is. I am going to start a plant where 1, 2, 3, 4, 5 missions are there. For each and every mission, there will be having a continuous input. Okay, this is input, 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 input. 1, 2, 3, 4, and 5. 5 different missions is having 5 different inputs. It is a continuous process. Now, after this, there will be having some 10 missions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 missions. This will be entering into these two, this will be entering into these two, this will be entering into these three, and this will be entering into this one, and this will be entering into this one. Whereas this mission was kept vacant. Now, this is what exactly mission utilization status is. Now, I am having 10 number of missions. All the 10 missions are utilizing the resources, power, human, everything. But out of these 10, what is happened? This mission is not having any workpiece with it. Or if the material is also, I mean, material is coming here, but the percentage from this one, it is 50 percentage, 50 percentage, it is divided. From the second mission, it is divided into 50 percentage, 50 percentage. Third mission, it is 33, 33, and 34. It is completely 100 percentage, whereas this mission is only 10 percentage and this mission is 90 percentage. Now out of these missions, which mission is not utilized up to the mark?
Last second.
Yes, this is ninth mission. Let us take an example, ninth mission. So ninth mission is not utilizing up to the mark.
Hello, sir.
Yes,
Can you repeat this?
yes, yes, yes.
Your voice is breaking, sir.
Fine, fine, no problem. I'll explain you. These are the inputs. Okay, my plant is having 5 different inputs, and for the initial process, this is 1. This is 1P, first process. This is 2P. In 1P, what is having? I'm having 5 different missions. 1, 2, 3, 4, 5 missions. In 2P, I'm having 10 missions. In 2P, I'm having 10M. In 1P, I am having 5M. In the first process, all the missions are utilizing up to its mark. In the second process, there are 10 missions. Out of 10, the first mission is giving the output to 1 and 2 in 50 percentage, 50 percentage. Second mission is giving 50 percentage to third as well as 50 percentage to fourth. Third mission is giving 35, 35, 35 percentage to 5, 6, and 7th mission. Fourth mission is giving 100% to directly 8th mission, whereas fifth mission is giving 10% to 9th mission and 90% to 10th mission. Okay. Now, out of these 10 missions, which mission is least utilized? That is what I have asked. Now, which mission is least utilized here?
Ninth one.
Ninth one. Why ninth one? Why ninth is?
Because of less
less number of workpiece are being given.
Yes.
So it is having less work.
Yes, it is having less pieces given to it, which is 10% of parts is given. But can I use this condition? This machine is using only limited number of workpieces, so can I reduce the power supply for this to run this machine? Is it possible? It is having limited parts. So what will be happen if I give a limited power to this to run this machine? Is it possible to run this machine with a limited power?
No, sir.
So which means the mission is common, the utilization is common, the resource utilization is common. For each and every mission, the resource utilization is common. Here there is a human involved in it. There are the resources like a human resources, electricity resources, place resources, coolant, tool, all the resources that are common for all the 10 missions. Whereas the output is not manageable. So this is called as a mission utilization status. Now I want to improvise this. To improvise this, again, instead of 90 and 10, I will be giving 50 and 50, so that I will try to maintain the mission utilization. So I will try to get that also, mission utilization out of these missions. If this mission is only utilized only 10%, we can't increase the 10%, then there will be alternate. I will directly remove this ninth mission from the process and directly give that 100% to the 10th mission directly. This is one of the alternative. Like this is called as a mission utilization status. So we can check, we are supposed to plan this also. What are the different processes that we are going to adapt? So if there will be having 10 missions, then out of 10, so are we using 10 missions, or are we using only 8 missions? Are we using 9 missions? Like we need to have some data on that also. Next one is tool requirements. We need to plan on the tool requirements. Why there is a need of planning on tool requirement? Hmm? See, in planning phase, there is this tool requirement. What is the need of tool requirement in planning phase?
We estimate if the tool is available for the process or not.
Yes. See here in 1P, there will be having 5 different processes. Out of these 5 processes, it is running continuously 24/7, and it is running for 365 days in a year. So out of a sudden, there is a tool breakage in the second mission. Now what happened? If I am having some stock with me or an alternative tool with me or some backup with me, then I'll try to replace the tool with a new tool, then I will run the process. If at all I'm not having the tool stock with me, then what happened? Then what going to happen?
So process 2 will stop.
Yes, the process 2, I mean the complete process 2 is stopped. The process 2 and the subordinate process and the subsequent process, all the process will go into halt because of this not working of second mission. So that is the one of the key factors. So before starting a plant or before doing that, so if at all I'm using some 100 CNC missions, so do I need to so I need to plan on the tools also. For 100 CNC missions, what are the different type of tools I need to require? So if at all I'm using some milling operation for on 100 tools, 100 CNC missions, then I should be having some sort of a milling tool, different type of milling tools. If at all there is an application that is causing that I will be needing for a drilling application, then in that application I need to have some drill bits with me with different diameter drill bits. So if I don't have that stock available with me, then what will be happen? I don't know when exactly it will going to fail, or when exactly the tool will going to fail. So it suddenly the tool will going to fail automatically. If at all I don't have any stock with me, then the process is going to halt. So this is also I need to plan based upon this. So this is a first set of planning phase. Clear?
So
Yes.
in machine utilization status, if that ninth and 10th one,
Hmm.
sir, if it is 10th one is capable of producing 90%, so can I extend it up to 100% like in fourth mission, and I can use the ninth machine as a backup machine?
Yes, I can use that. That is what exactly machine utilization strategy is. We can check that. We can check the characteristics, statistics. So what will be happen if I use it for 100%? So will this machine able to run continuously for 24/7, or will the machine need any some sort of rest after a day or after a week? Like I need to collect some machine utilization statistics in this planning phase only. So as you said, I need to create this complete plant in the simulation. I will check on what will be the maximum condition till this will work. So this 33 phase, maybe this fifth mission is going to fail at some condition. Now what will be the alternative for this? Because of this the process is going to fail, or it will be having limited number of parts. At that condition, what will be the alternative? So do, if at all I am using some alternative mission, then what will be the load on that mission? So all those things that can be checked on this mission utilization status. We can check the different scenarios, like as you said, if at all what will be happen if I use 100% to that mission and I'll use this ninth mission as a backup. So what will be happen if I give 50-50 to this? Like we can check any type of permutation and combination on this thing with this mission utilization status. Okay.
Okay, sir.
Okay, so in software we will be having some set of charts. I will be explaining you all those things when I have shown you the software. In that there will be having some set of these bar diagrams where you will be clearly visible, like what will be the mission utilization, how much time it is ideal in state. So if the mission is having a failure, so how much time it is in failure condition. So if the mission is in a blocked phase, how much time it will be in blocked phase. All those things can be checked by using a chart. So by considering the chart as a reference, we can alter the production. We can use the, I mean, we can reduce or we can reuse the missions based upon that. Okay. Fine. Now coming into second phase, that is nothing but manufacturing phase. Till now we are in the production planning phase. Now we are searching for the manufacture planning. In that manufacturing planning, so we are going to consider these four essential things. First one is minimizing the changeovers. Now what is this minimizing the changeover? Have you hear this word changeovers? In industry, if there will be having, let us take an example. There are two missions, first mission and second mission. This mission is continuously running for 12 hours. After 12 hours, this mission need to be paused, this mission need to be stopped, and we need to do some maintenance for this one. For the next second hours, we need to go to this mission and we need to run this 12 to 24 hours, 1 to 12, 12 to 24. Again after this, again we will going to come to this mission and we are going to maintain this mission. So I'll call this as a changeover in one perspective. Okay, changing from one mission to another mission is a changeover. This is one perspective. In a continuous running plant, okay, changeover is completely different. This changeover is nothing but if there is a CNC machine is there and there will be having two conveyors. Okay, this is mission X, this is A, and this is B. Mission X is having two inputs, one is A and one is B. Both are different, both are different parts. For this operation, A is like this one and B is like this one. So two different components, we need to do this type of operation, but the input is same. The input is this one. Okay, so here there will be having some input and here this part is coming in this shape and this part in this coming in, this is A and this is B. So in this mission I am going to make a hole at this one. Here I am going to make a hole at this corner. Okay, now I want, this is a CNC drilling mission. I have CNC milling mission where we are going to go for the drilling operation. Now part A is coming, there is some set of A program. So if A program is running, A part is coming here. So this is the A part and some set of drilling operation was done. Now this part will be entering into second conveyor. Now second part is coming from B. Second part is nothing but it should be like this. Now what will happen if I run the A operation here? This machine is already loaded with A operation. Now how can it supposed to convert into B operation? First of all, clear? What I am explaining is clear or do I need to explain again? There is a mission, CNC mission, which tends to do the drilling operation. Okay, that mission is having two inputs. One is A and second one is B. One is having, one I need to do the hole at this corner and B I need to do the hole at this corner. So these are the two different areas. Now the part is, A part is coming to the mission and this CNC mission is having A program loaded in it. So A program is loaded. So I have done this cutting section, drilling section. Once the part was done, now the part is entering into A conveyor, A exit conveyor. Now the B part need to enter into mission. Now the program that is loaded in the CNC mission is A. Now how can I supposed to change this one? I'm not going to do this A operation to B part. Why? Because B program need to operate on the B part. Now this conversion from A to B is called as a changeover. Okay. So there need to be an operator here, CNC X operator. This CNC operator come here and he need to shift the program from A to B and he need to run the program. Then the B program, the whole which I need to, that will be programmed and the part need to be entered here. Again A part will be entered. Again this programmer need to change the program to A section. Like this CNC operator need to continuously change over from A to B, A to B, A to B. Then only my parts will be coming like this. So this is called as a changeover. Now if at all I want to minimize this, then how exactly I need to do this? If at all I want to minimize this changeover, because of this what will be happen, my time will be wasting. For complete changeover, for changing from A to B, it will need 5 minutes of time. Why? Because for program changing it will be needing 2 minutes. At the same time there will be a zig and fixer, which means the part that need to be hold to the mission wise, that need to be mounted. For each and every operation it will be needing 5 minutes of time for changeover, and for this operation it will be needing 1 minute. Now it's a failure or it's a efficient one? Now you tell me.
So either we can input another machine, another drilling machine, or either we can specify the time that for set of time duration, only A will come, and after that, after programming is done, then B will come.
Yes, these are the different alternatives we can adopt. Like you said, so first I need to complete the A stock completely. Once the A stock was done, then I will be starting B. For every hour, for first hour, this will be done. For the second hour, this will be done. So this is one of the alternative. Second alternative is I want to add some one directly mission so that the production is not going to halt if it is a continuous. So these are the different alternatives. So instead of going for a changeover, I want to add some alternative for this. This is called as a changeover. Clear? If it is having a limited number of parts, which means for every 1 hour one part is coming, let us assume for every 1 hour one part is coming here, one part is coming here, the processing time is 10 minutes. Now at this condition, is it acceptable or not? So this is the condition.
Yes.
For every 1 hour
Yes, sir.
A part is coming, for every 1 hour B part is coming. How much time it will be taking?
Yes, sir.
10 minutes for processing, 10 minutes for processing. At this condition, this is acceptable. If it is a continuous, this is a not acceptable thing. Then we need to check on these aspects also. If the machine is having continuous changeovers, then we need to replace the process or we need to find some alternative. That is called as a minimizing the changeovers. Second one is reducing the bottleneck. Just a second, let me change the ink. Okay, reducing the bottleneck. Here, if at all I will be using 15 minutes for A and 15 minutes for B. Now this first part will be entering, every part will be entering into mission. In this B conveyor, what will be happened? Parts will be waiting here. Okay, parts will be waiting for operation. This is called as a, this phase is called as a bottleneck. Okay, in technically we'll call it as a bottleneck. In other words, we'll call it as a work in progress also. Clear? Bottleneck is nothing but the part is waiting for the mission. That is called as a bottleneck. The mission, this is a mission and this mission is having some part and some processing is happening, and in this conveyor there is a part that is waiting for this mission. Then I'll call this as a bottleneck of this process or bottleneck of this complete process. So I want to reduce that also. Why there is a need of reducing that? What is the impact of bottleneck?
So to save time.
Yes, to save time. At the same time, what will be happen if the material is completely logging here? Finally,
Sir,
this,
bottleneck means the workpiece.
not the workpiece,
They are
the
using to enter
condition,
in.
the condition of the workpiece. Here the workpiece is waiting for the mission. This condition is called as a bottleneck. The workpieces are waiting here. This is called as a bottleneck. Clear?
Okay, sir. Means it is a time actually.
It's a time only. Bottleneck is a irrespective of time.
Okay, okay.
Okay, that is a bottleneck. Next one is optimizing the resources. Now you explain me what is this point. Optimizing the resources, what exactly it describes?
Best utilization of all the available resources.
Yes, best utilization of all the available resources. Like in the previous example, we have used P1 as well as P2. In the P1, I will be having 5 missions. In the P2, I will be having some 10 missions. Out of the 10, one mission is not utilizing up to the mark. I want to check this aspect, how to reduce this one, how to utilize this one. So instead of using 10 missions, or instead of using 9 missions, or if there is a 10th mission is there which is not utilized up to its mark, then I am going to completely remove that mission and I am going to run the mission with respect to 9 missions only. With this, I am going to check what will be the impact factor. If at all I am matching the actual production with the ninth missions, then I am going to utilize that. This is what exactly optimizing the resources. All the capabilities, all the necessary things for a mission or a plant to run the process. So we are going to optimize that, whether it may be a mission or whether it may be a human. Like in the previous example, we have discussed this also. Here there are 9 missions are there. Okay, and now let's not talk about the 9. Here there are 5 missions. These 5 missions, a human is needed, okay, to operate this mission. A human comes here, he need to on this mission. Same, if at all 5 humans will be needed here, we are assigning 5 different humans here to come here to on the mission and to stay over there for the rest of the day. Okay, now how can I suppose to optimize this one? There is no any other other option, other area, other working area for this one, for this human. He need to come to his location, he need to on the mission, and he need to be at that location for the rest, 8 hours or 9 hours shift. If this is the condition, so I am implying h1 h2, like there are 5 humans. Now I want to optimize this one. How to optimize this for? How to optimize this model? Resource optimization. I want to do the resource optimization at this one. How can I supposed to do the resource optimization in this extent? What will be the method? Here there are 5 humans. So instead of 5 humans, what will be happen if I use only one human? So this human will come here. He comes here. He first on the mission, and he will be going to second mission. He will on the mission. Same third, fourth, fifth mission. He has on all the missions. He has given power supply to each and every mission. Then he is going to monitor all the missions continuously. He come for 5 minutes here, after that he will be entering 5 minutes here, after that he will be entering 5 minutes here, 5 minutes, 5 minutes. Regularly he is doing the same task. Then this is a optimizing resources only. Why? Because previously I am using 5 human for the same application. Instead of 5, I am using only one human at this application. This is I called as a optimization of resources somewhat. Okay, next one
Oh,
is impact of failures. Now what will be the impact of failure? Now you only tell me this one. I have given you this much of examples. Now you explain me what exactly this impact of failures is.
So suppose we are using 5 CNC machine for production of any product, and they are means step by step we are using it, and one machine failed, so another two machines input will stop and production will stop. So we have to think of the impact, means what will happen after if this fails.
Yes, that is a correct one. See, we will be, as said in the example, there will be having a 5 CNC missions. We need to know each and every detail of this mission. If the first mission was failed, now what will be the impact? How can I supposed to overcome this one? What will be the alternative method for this? So how to overcome this? So how much time it will be taking for this one first mission? Empty. How much time it will taking to repair it? MTTR, all those things. Now the same thing. So what will be happen if the failure is happened with the second mission? First mission is running perfectly and second mission is having a failure. Now what will be happen with this second mission? So how much time it will be getting back to its original condition? So what will be the alternative for this mission? Where exactly this alternative mission is there? Now the for the third mission. So if the third mission was failure was there, So if there is an alternative mission, we can provide anything, we can do the alternative method. If there is no any alternative mission for this, except for this third mission, this is exceptional mission, now what will be happen to my production? So what will be happen for this fourth, what will be happen for this fifth? Like we need to have some set of data with which at each and every process, at each and every mission, so what will be happen if there is a sudden impact, what will be happen if the complete process was failed? So till now we have discussed about first one mission, two mission, three mission, single mission failed. Now what will be happen if the complete process was failed? Okay, the process which I am going to adopt is completely failed. Finally I am going to manufacture this type of component. Now I am getting some this type of component, this complete process was failed. Now what will be happen if the complete process was failed? What will be its impact? This is the first process and the first process failed. Now how can I supposed to go for the second process without having the first material? Like I need to have some complete data on all these things, that is called as a impact of failure. Okay, and the final phase in this plant simulation is nothing but a project phase. So we'll be having some planning phase, we will be having some manufacture planning, now we will be having some project planning for this simulation. On this we will be utilizing the energy efficient missions. The first point is energy efficient missions. Okay, I will give you simple example. Conventional mission, CNC mission. The application is, okay, just to remove the excess material on these phases, which means chamfer. I hope you know chamfer is. Okay, I need to remove just 2 centimeters of material on all the sides of this one to chamfer it. So this is the application. In conventional mission it will take 5 minutes, in CNC mission it will take 2 minutes. The number of parts, that is continuous, 10,000. Same here, it is also 10,000. The cost for doing this project is
Excuse me.
yes.
So what is chamfer?
Okay, fine. See, if the part, this is the side view of a part, if at all I want to remove this area corner, okay, I want to remove this complete corner and finally my part will be like this. This is called chamfer, edge removing. Okay,
Okay, sir.
in 3D it will be like this.
Okay, sir.
Okay, this is chamfer, this is having a flat surface. One more thing is there, that is called as a fillet. Fillet is having a curved surface. Okay, this is chamfer and this is fillet. Now this is a simple application. Why? Because all we need is just a milling tool. If there is a milling tool, automatically it will cut this material directly. So this is a simple application. In this application it will take 5 minutes. Why? Because there are 4 sides that need to be chamfered. In conventional machine it will take 5 minutes, in CNC machine it is taking 2 minutes. The cost for which is, for every 100 parts it will be charging 1000 rupees, 1000 rupees per 100 parts. Just a second. Yes, for every 1000 parts there will be needing 100. For every 1000 parts it is no, for 100 parts it will be charging 1000 rupees in conventional mission. Whereas in conventional mission it is charging for every 1000 parts, for, sorry, it is charging 10,000 per 100 parts. Okay, so this is the statistics. Time is this one, this is cost. As I said, simulation is based, I mean 3D, 4th D and 5th D. 3 dimensional, I am having this 3 dimensional component with me. 4th dimension is nothing but time. Time is having 5 minutes here and 2 minutes here. 5th dimension is cost. Cost for producing 100 parts is 1000 rupees, cost for producing 100 parts is 10,000 rupees. So this is the thing. Now which one I want to produce, I mean utilize, which one I am going to pick out of these two? Which one I am going to pick, whether a conventional or a CNC?
So CNC.
Okay, and one more thing here, uh, it is charging some 1 megawatt per day. It is charging some 40 megawatts. per day. Now
Conventional.
power utilization, see the power utilization is this much, here the power utilization is this much. I need to consider the cost of this also. For 1 megawatt it will be charging some 1 lakh of rupees. Let us take an example of 1 lakh for 1 megawatt. Here how much it is? A 40 lakhs for the same. So at this condition, of which one I am going to pick? I'll definitely go for this conventional machining. Why? Because
Yes.
the end application is simple application. Here there is no need of the surface finish. I mean, there is no any rocket science involved in it. There is no any complications involved in it. This is a simple application where I am going to remove this material with a simple tool. In a one operation, it will be performed. So in this operation, I will definitely go for the conventional. If there is having a hole involved in it, one, two, three, if there is having four holes involved in it, then definitely I will be go for conventional machining. Why? Because I can't produce the same thing in in a conventional machine. I can't produce the same distance. I can't even go for the repeatability in this aspect. Whereas in this one, I will try to get it. So based upon the application only, we will be going which mission will be utilized. That is called as energy efficient missions. Utilization of energy efficient missions. So for the what type of application we are going to use, the application will be precise application or it is a smoother application, simple application. Based upon the application, we are going to check conventional or a CNC. Okay, that is it.
Sir, sir, when if we will remove the power aspect, so will we use conventional or CNC?
Same thing in perspective, company's perspective. The end application is simple, then definitely the company will go for this conventional only. Why? Because yes.
Sir, because the product amount is also.
Hello. Sorry, your voice was not. Your connection was lost. Am I
Sir,
audible?
yes,
Yeah.
hello.
Yes. Yes. Yes.
Sir, I am saying that the amount 10,000 is also higher, so human labor required will also be higher.
Hmm.
So, means how we will decide about it if we will remove the power aspect.
Okay, if there is no any power aspect, then we will be discussing on the this application base. If the application is complex one, then definitely no any, skilled labor is also definitely needed for this conventional mission. Even the skilled labor is there, we can't even produce the that much of complex parts in this one conventional mission. If at all I'm going to do this fillet, see fillet is a curved area. So this curved area, maybe it's a difficult in this conventional machining. If it is a difficult, then at that application definitely even the cost is more, then I'll definitely go for this CNC missions. Based upon the application only, I will be deciding. It is a simple application, so I will be picking conventional machining. I will be giving some human, direct human here, so he will do this part. So in your condition, in this condition, if at all I use a CNC mission for this application, now what will be happen? My time will be less. I am getting more number of parts, but a human is needed. Definitely a skilled human is needed. At the same time, the part for which the cost is also increased. All those things will be increased. So at this instant, I am not going to use this one. Instead of it, I will be using two or three CNC, conventional missions here. So instead of this one, I will be using two conventional missions or three conventional missions. I am giving some human here, and I will try to use this one. So what will be happening? Even the production is continuous, then nothing will going to impact for me. Automatically, I will try to get this production. This is some alternatives based upon the company's perspective. But in general, conventional is the best for the based upon the application. If it is simple application, then conventional is the best. If it is a complicated application, then definitely there is no, alternative. So we have to go for the CNC mission, irrespective of the power. Okay.
Okay, sir.
Even not only for this, there is an application where this is the first mission here, and there is second mission is here. Hardly it will be having some 100 centimeters apart. Okay, 100 cm apart. Now will there be need of conveyor?
No, sir.
There is
Means.
for every 1 minute one part is coming at this time. So for every 1 minute a part is entering into second mission by somehow, by human or by conveyors, different aspects. Now is it necessary for a conveyor at this small application?
No, sir, not required.
I hope no. Why? Because this is a smaller application and the material, I mean, the distance between these two missions will be less. So I will try to use some human over there. Why? Because this operator itself to do this operation, or I will place some bin over there directly. Once the bin is having some 50 parts or 60 parts, then I will try to load this bin to this mission, come to carry this mission to this one. Now in this condition I need to check, so will conveyor will give maybe efficiency increased, or whether I need not need to use any conveyor in this application, like based upon this only. So on what basis I need to go for the automation, where exactly the energy will be utilized, or where energy I need to restrain my energy resources. So how I need to save my energy, at what application I need to use my energy, and what applications I'm not going to use the energy, like different alternative ideas I need to check in this perspective also. Okay, next one is alternative methods for improving the throughput. Now I will explain you regarding the throughput. This is one of the keyword. Throughput is nothing but, if this is a mission, okay, in top view it is a mission, there is a conveyor and there is a conveyor. Two, three, 4, 3, 2, and first part is in the mission. This is IP input, this is OP output. Now a part is entering into the mission, okay, this part is the first part already entered into the mission. Now this mission throughput TP is 1, okay. Once this operation was done, then what will be happened, this will be entering into this conveyor. Now it is having second part, okay, this part entered into this mission. Now this mission throughput is having 2, okay. Once the processing was done, the second part will be entering here in the conveyor. Now third part is entering here, so the throughput is 3. Like if the machine is having 100 parts in the conveyor and 99th part is processing here and 98 parts are on the outer conveyor, then the throughput of the machine is 99, TP is 99. If the mission is having some 5442 missions, 5442 parts in the conveyor, and the mission is having 5421th part here, and this conveyor is having 5420, then if I call what is the throughput of this mission is, then throughput of the mission is 5421 is throughput. Now what is a throughput?
Sir, how much product it has
Sorry, Mr. Rishabh, your
Sir,
voice. Can you repeat it?
throughput is the
Uh,
sir, throughput is the amount of product or means quantity of the product it has processed.
Not processed. Processed is
Number
nothing
of
but,
product.
yes, process is nothing but this is processed products. This is going to process. This one is processing. Okay. In
Yes, sir.
simply, the occupancy of the mission. Okay. The number of parts that are entered into a mission is nothing but a throughput of a mission. Okay. The number of parts that are entered into the mission, the number of parts that are in the mission, that are performed in a mission is nothing but this one. See, throughput is nothing but 99th part is processed, so the throughput is 99. And once it was done, then 99th part will be here. The throughput of the machine is 99. If the 100th part entered, then the throughput of the machine is 100. So the occupancy of the machine, how many parts it was going to produce, or it is producing at that point of time, is nothing but a throughput. Okay. Why? Because this is one of the thing which we are going to do the analysis part in the simulation also. We are going to calculate the throughput analysis. There is a one more thing, throughput analysis, that is in one of the main thing in the plant simulation software, where we are going to check each and every mission for the throughput. How much throughput is there? I mean, how much utilization is there for a mission? So, with respect to the part, throughput is nothing but with respect to part only. So why? Because the part is the thing which is entering into the mission. So we are going to do this throughput analysis for the mission, which means how many parts will be entered. So what is the time of the thing? How much time it will be taking? So with this I can estimate. Just a second. Let me erase this thing and I'll explain you. See, there is a mission here, and there is a conveyor, and there is a conveyor here. some 50th part is processing here. So here how many parts it will be? In the output, how many parts it will be?
49.
So there will be having 49 parts in the output conveyor, and there will be having some 100 parts here that will be left. Okay. So now for each and every part, it will be taking 2 minutes of time. So if the 50th part is processing, how much time total it was produced as of now? I have given you a simple condition. 50th part is processing here. Okay. It was just started. So already 49 parts were already processed. For each and every part, it will be 2 minutes of processing time. So how much total time till now? So what is the total time?
98.
98 minutes.
Okay, it's 98 minutes.
98 to 100.
Okay, 98 minutes. Now, what is the total time for completing the cycle?
200 minutes.
Yes, the input is 100. Out of the 100, 50 parts will be entered. So total input is 100. The cycle time will be 200 is the cycle time. So we can calculate with respect to throughput. So if the part is continuous, just a second. Guys, is there any disturbance from my side? Hello.
Now it's okay.
What happened? Just okay, fine. Yes, it's running, right? Okay, fine. Now the cycle time is 200, right? Now with this I can calculate what will be
Yes, sir.
happened if at all I want to run this process for complete a day for 24 hours. How many parts I can manage? If at all I want to run this plant for 365 days, how many parts I am going to produce after 365 days? Like I will be getting all these data with throughput analysis.
Hello.
Just a second. Hello.
Where is it going, my voice?
My connection got interrupted.
Your voice is going.
Is it okay?
Yes, 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 yes. I think you're using two devices, that's why it is.
Hello. Is it clear?
Yes, sir. Yes, sir.
Where are we? So, okay, I hope you are thorough with this throughput, right? Is it clear with the throughput?
So I have one question. That
Yes.
hello.
Yes, yes.
So if we process two items at a time, then our through output will be two.
Yes.
Means if we process 49 and 50 together, so our TP equal to 49 and 50.
No, 50. The maximum figure. The parts, the maximum figure that is involved in a mission. It's not on the which part. It is the how many parts we are going to, process at that time.
Okay.
Okay, no worries, I will show you when the software when I run the software, then I will be showing you all these things in clear. Okay, then involvement of automation. So where exactly the automation need to be involved? Like in the previous example, I have used some conveyor example. So this is a mission and there is a mission. Out of the distance between these two missions is 10 meters. Now, is it necessary for a conveyor or do I need some alternative things? So, or else if I use some AGV here, automated guided vehicle here, to put the material here, and it will be reaching to this location which is 10 meters apart, and it will be giving material to the station. Now, is it acceptable? Which is not acceptable. So we need to check on on what capabilities we have to check this automation, where exactly we are going to involve automation. All those things we have also consider before starting a planned project. So this is completely for a newer project. If it is a newer project, then we are going to consider different areas like planning phase, manufacturing planning, as well as project planning. So once we will be having all these things with us, then it is our response. I mean, the software is having with us, so directly we can go for a model. Why? Because why all these things will be needed is, let me show you. I have prepared a layout like this. See, this is my layout. First mission, second mission, third, fourth, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 missions are there in this model. Now I have done some optimization, some I have done some modifications in it. In that, the model is showing this is not the correct manner. So instead of it, the plant asked me to, let me change the color. So instead of it, if I go like this, it will be easier one for material movement. It has given me this type of condition. I mean, if at all I use this type of facility, this type of green layout, then there will be having limited logistics, limited material movement rate, limited all the things, human involvement, all those things in this one. If I got this thing, so this is a second and red one is one. So if I got this type of upgradation, then I need to have whether this upgradation will be feasible for my model or not, whether I am having a place which will be fit for this, sorry, whether I am having a place that will be fixed to this layout or not. What will be happen if I type this type of layout? How can I supposed to move the material handling on all these stations? Like, if at all I'm having all these things with me, then it is easier for me to do the alternatives, to do the modifications in a plant which I have created the model. Okay. Now, in our industry, there will be having lot of simulation softwares. Like if we are going to do the plant, I mean layout as well as facility optimization or facility simulation, we'll call it as a plant simulation. So if we are working on the robotic part, then we'll call it as a robotic simulation. If we are working on the process, which means a car is coming at each and every station, the car is moving in some direction in a special process, then we'll call it as a process simulation. These are all some of the industry digitalization softwares which will be 4.0. Okay, any doubts in this slide? Clear?
No, sir.
I will be showing you a software, I mean a video. So this is what exactly a software look like. Don't worry, I will show you the software later on. First, I will give you a glimpse on what exactly the software is capable of. Is it visible? The material movement?
Yes, sir.
Yes, sir. Yes, sir.
See how the material is loading at the station, and after that how it was be dispatched to the next station where the robots are doing the pick and place operation, material handling operation. After that it has given to the conveyors, automated things. Again, some robots will be assigned where the parts will be loaded and placed on the material conveyors, and the empty bins will be reaching to some other location for final parts. Whereas in this application, see, the parts will be entering into these missions. Automated processing will be happening here. So with respect to some automation, some automated process will be happening. Again, a human is coming here for picking a part and placing it somewhere. See, he's picking a part and he's doing the material handling application. This material handling was done, then the part will be entering into next subsequent station or the next subsequent process where the material is going for a painting phase. Here, see, the color of the object will going to change. So this is how the part will be. So once the part will be reached, it will be entering into next phase. Like the what is the described based upon the process of the plant. So if the plant is having n number of missions, n number of processes, then the part need to go through all the points. So and we need to check on each and every parameter how the part will be behaving at each and every parameter, how the human is involving, how much time the human is at the station, how much time the mission is running. If there is a failure in this mission, so how much time the mission is having a failure, so what will be the impact of the mission, what will be the impact of failure on the next process, all those things we can check in this software. See here, the empty bins from the starting process is come here, and the robot is picking the parts and placing on the again and the empty bins. So once it was done, the parts will be again, it will be reaching to some other station. These things, I hope it was visible. See my cursor, this is called as a AGV, automated guided vehicle. It will follow the trace. It will follow the yellow line which was defined automatically without any. This vehicle is not having any driver. So automatically, by following the track, it will be going to the final destination. Its destination. Now see, this programmer is come here. He has given some condition to the robot, and automatically the parts will be entering into the next subsequent station. See here, next subsequent station, and here the robot is picking the parts and placing on the AGV that was defined, and once the AGV was full, it will be reaching to the next station, that is nothing but final packing station. Again, in this packing section, this is called as a it is completely automated, where the parts from different intervals coming to this station, and the part will be picking how much time it will be doing the operation, how much time it is in arrival time, all the things we can calculate here, and the parts will be coming here. It will be placed on a pallet, wooden pallet. See here, different colors, both will be distinguished here. One sort of operations will be placed here, one sort of dark components will be placed on this pallet. Once the both were done, this pallet will be reaching to the next subsequent station. See here, the parts will be coming here. And it will be entering into this storage. This is called as a ASR, automatic storage as well as retrieval system, where this complete system is works on the algorithms as well as programming, which means wherever the least possibility is there, wherever the component is waiting, I mean the emptiness is there, automatically by based upon the algorithms which we have defined, so it will be storing over there. The same application for the retrieval also, there will be having some load trucks will be there. Once the time is once the call was there, then automatically the material will be unloaded from this ASR and it will be entering into these trucks. So this is what exactly the plant simulation is, which means from starting of material to the end stage, everything we can define here. See, as I said, these are the charts, resource charts, how the mission will be performed, what will be the utilization status. Here there will be having pallets. See, empty pallets, how the pallet will be picking, how the pallet will be coming. After that, the pallet will be placed here, it will be reaching to final destination, its destination, and it will be waiting for the condition. So how it was happening, and each and every step there will be having some inspection also, how the inspections will be performed at each and every step, all those things can also be monitored in this software. Okay, this is called as a plant simulation. We can, okay, see here, this is called as a Sankey diagram. I will show you this also. Sankey diagram is nothing but, when I show you the software, I will explain you this. Sankey diagram is a material flow, how the material is flowing, when what aspects the material flow is more. Don't worry, I will show you now itself. Show diagram. Is it visible? Green lines. Visible, guys? There are some set of green lines, which means the material movement. Here there is a thick green line, which means here the material movement is more, whereas here the material movement is dull, I mean less. That is why there is a thinner line. Same here, the human is picking the part and placing this, so there is a limited, I mean limited thing. That is why it is having a limited thing. See here, for every machine there will be having a small thin line, and finally from this conveyor there will be having a thick line, which means the material movement is more here. Same with this one. So even in the last, here the metal is coming here and it will be deviating. So here the AGV is picking the material and it is carrying to the next station. And finally here the material is also coming here. There will be having a lot of material that will be entering into ASR. So Sankey diagrams are nothing but material flow, how the material flow will be there. So if at all you want to check, that can also be possible. Like I said, there is a cost analyzer also. If at all I want to run this complete mission, what will be the cost? How much cost will be there? So if at all I want to produce this report, I want to submit this report to some other organization, then how exactly the report will be? I can showcase that also. See here, show report. Visible? See, this is the report and all the data sticks. How much time, how much line, everything, P1, P2, drawing, line thing, how much everything involved in it, investment costs, all the things involved in it will be abbreviated here in this document. Clear?
Yes, sir. Yes, sir.
These things we are going to learn after this basic session. Okay, how to create this, not only this plant, this is a, I mean, complex plant. So initially we'll start with a basic plant, how the basic plants will be monitored, how it was created, how it was balanced. Once you are having complete hands-on experience, then you are able to then you are capable of preparing this much of complex layouts. Okay, now I will close this. Okay, these things I will be discussing on tomorrow's session. Okay, anything so far, any doubt so far regarding the plant simulation, regarding the things which you are going to start? Still, if you are having anything, then no, don't worry, tomorrow I'll explain you again all these things by showing you a software, videos, all those things, so that you will be having clear idea on what exactly the software is, or how exactly we are going to do on a step-by-step procedure. This is the procedure. So if at all I want to start a model, so how exactly it will be modeled. So what are the different conditions I need to adopt? If at all I'm using for a newer plan, then what will be things? If it is existing plan, then what is the things which we need to consider? By using the simulation, what we can increase or what we can determine, what we can decrease, all these things. Like I will explain you all these things in tomorrow's session. Okay,
Okay, sir.
Okay, sir.
clear so far?
Yes, sir.
Yes, sir.
Fine. So from tomorrow onwards, I am not reminding you to join at 9:30. Kindly join by 9:30. Okay, we'll start the session by 9:30 itself. Fine.
Okay, sir.
Yes,
Okay,
sir.
sir.
Okay then, guys. Bye. Have a great day.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you very much.
Thank you, sir.
Okay.
Thank you, sir.
Thank you.
Thank you. Sir,
Yes.
hello.
Yes.
Sir, I have a doubt that if this is virtual and in industry there is difference between virtual and reality, so how we will overcome that margin? Means like suppose if workers are at strike, okay, at some industry which are manually operated,
Hmm.
workers are at we will overcome, not overcome means how we will overcome that margin that we are thinking in virtual, that the worker will be working regularly, he will not be absent or he will not fall ill or any other circumstances. Suppose there is a power shortage or power cut, then how we will find that margin between the virtuality and reality,
Yes.
between virtual and
Got it.
reality?
Here we are not assigning the workers for 24/7. There will be using some shifts. Okay, we are using some shifts like 8 hours, and there will be having a breakage for every hour or for every 2 hours. If the work is complex, then there will be having a break after every hour. Like we will be giving each and everything with respect to human. As said, there will be having a power cuts, we will be giving some losses, I mean some exceptional things. So what will be happen if there will be having power loss? So what will be happen, that is what exactly I said, what will be happen if the complete process failed? Process failed is nothing but a power failure. So if there is a power failure was there, suppose industry should suppose have a backup generators, but that industry backup generators won't give power to each and every mission. So it will be giving to the essential missions. So what are those essential missions? I can pick that, I can give all the statistics. But if the employees are not coming, if the employees are on strike, those are exceptional things which we are, I mean, not considering in the initial phases. So we are preparing the plant for a continuous run, which means so I am having some 100 employees. Out of 100 employees, for general shift 30 were coming, for remaining shifts 20 20 20, that like I have divided the complete 100% in the plant. So I can prepare the model by using that. So what will be happen if the A shift is having 30, B shift is having 30, and C shift is having 30? So I am having 90%. So by using 90%, up to what extent I can run the plant? I can manage that. In between, if the company, if the employee is not coming, if the employee has left the organization, those are exceptional things which we are not involved in this plant simulation. Okay.
Yes, sir, I am understanding that. I am asking that how we will find the
Yes.
margin, like difference between reality minus virtuality,
That is what
like this.
exactly validating as well as analyzing. There is one more thing I am going to explain you in tomorrow's phase. In that there is a procedure. So after validating, there is a part of analyzing. In that analyzing, you are going to check. In actual, you are getting 60 percentage, whereas in a virtual platform, I am given 80 percentage of. So what is the margin? Why there is a 20 percentage of differ? In that, you have to add all those things physically, which means the company is not running up to its mark. The employees are not in the mark, and there will be having some strikes. Like they will going to support all the documents with respect to that. See, if at all I am the company owner and I have given a project to some simulation department to do this analysis. So now I have to submit it to my CEO. So what is exactly the actual and what exactly the virtual, and I have to submit the difference also. I have to submit some reports on the difference at that point of time. So I'll collect the virtual results. From virtual results, I will be having some 80 percentage of value. In actual, I'm getting 60 percentage of. For the 20%, I have give all the causes which will be defined. Like as you said, there will be having employee shortage, there will be having a power failure, there will be having a resource failure, there will be having some unconditional, which means some there will be having cyclones will be there will be having some shortage will be there. Like I need to add all those additional in physical manner, which is not able to add in the software. Those are supporting documents that will support my, I mean, actual thing. So those things I can add and I can give it to in a brief report to my superiors or some organization who is going to verify it or validate it.
Okay, sir.
Okay, fine.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Thank you.
Sir,
Yes.
sir, any news about reopening of college?
No, as of now, no any information. Even in NIT itself, some cases were identified in mechanical department. So no any official news as of now.
Okay, sir.
Okay, thank you. Hello. Hello. Yeah, good afternoon. Okay. Okay. It is. No, it is not possible. Why? Because UAD is also generated, but uh, y- you have a feasibility. Once you are having software with you, I mean, once you learn the software here, then you will be having some 45 days of time. In that, you can do n number of projects. You can do all 14 also if you want. You can. But for the submission, you can do this only. Why? Because UAD is generated. We have given that to NIT. Okay. Thank you.